Today we're going to be talking about multi-node test integration using Kitchen, Terraform, and Ceph InSpec all together. My name's Lance Albertson. I'm the director of the Open Source Lab. A little bit more about me. I've been at the lab since about 2007. I started out as a sysadmin and then I was promoted to director, but I basically do everything there now. I manage about 7 to 10 undergraduate students throughout the year and help them mentor them on doing all the management tasks they need to do. I'm also active in the FOSS community. Early on, I was involved with the Gen 2 infrastructure for quite a few years. I was also part of the Ganeti community, which is a virtualization platform before OpenStack even existed. And of course, I've been quite active in the last few years with Ceph, with the Sync project. And I recently started to maintain the Kitchen OpenStack and Knife OpenStack plugins and various things. I'm also one of the primary maintainers of the OpenStack Ceph cookbooks as well. So I've been quite busy on that side of it as well. A little bit more about the organization. So we're at Oregon State University. We've been around since about 2003, and we basically provide infrastructure hosting for medium to large open source projects. We currently host over 200 projects, but really it's more than that because some of the projects have sub-projects like the Apache Software Foundation. You know, they have probably over 1,000. I don't know how many projects they have. But we provide a variety of server co-location hosting. We also have private cloud hosting. We have a popular software mirror, our FTP-osuosl.org. And we also provide managed hosting, which we use a lot with Ceph Infra on a lot of our stuff. So that's a lot of what we do. And then the flip side of it is that we provide experiential learning to undergraduate students. So they get really good hands-on experience managing all these systems, and they interact with the open source communities. They get an experience of what it's like to, to have a customer and kind of interact with them online. And then I do my best to kind of teach them current DevOps practices and technology so that when they get out into the real world, they're a step ahead of everybody else. And a lot of our alumni are really well known in the open source community. Some of our notable ones are Alex Polvey, who created CoreOS, among many other things that have been going on. And so we're quite active in the ecosystem. Currently, I'm the only full-timer, and I have 8 undergraduate students. So yeah, let's actually dive into what we're going to be talking today. So first off, let's talk about what is multi-node testing and why is it important. I'll talk about the tools that kind of make multi-node testing, and then I'll show you kind of a demo, real-world example, and then we'll talk a little bit how you can replicate this in your environment. So first off, what is multi-node testing? Well, it's the ability to deploy multiple nodes and see how they interact with each other. So typically with Test Kitchen, you're deploying a single node and you're running single tests upon it. And most of the time, that's really all you need. But when you get into more complicated systems, you need to have a little bit more ability to test these things. And you want to be able to spin these things up and tear them down as quickly as you do with Test Kitchen. Now, Test Kitchen's design really wasn't meant to do multi-node ability. It's really just to be, okay, can I run this recipe and does it do all the things it needs to do? The other thing that we need to do is we need to be able to add tests that maybe run on all of the nodes or individual nodes and so forth. Some of these complex test systems that I've had experience doing that internally is OpenStack, actually, is one of the very first ones. Ceph is another one. We've been doing H8 MySQL, H8 Proxy, Keep Alive D, those types of things and a few other things, but it's been really nice to be able to spin those up. And it also opens up a lot of ability to see like, oh, hey, I didn't realize this was an issue when I got it going in multi-node. And it's usually either something isn't binding on the correct IP address, maybe it's only set to local hosts, maybe you have a firewall and you don't have it quite set up correctly. Those types of issues are really difficult to see unless you actually get it deployed into the wild, and that's usually too late. The other thing that it's really good with is it replicates the production environment a little bit more closely. So you can, if you want to see how this interacts and works in a more production environment, you can do that really easily. You can also add some certain test scenarios if you want to see if things are changing. And the other thing that I've been using is if we have an issue in production, it's always nice to be able to see, can I replicate this somewhere else? And maybe sometimes you can't quite replicate it on a single node. So here we can deploy multiple nodes and see if we can replicate that issue. And that's been really useful. The other thing that's been extremely useful is testing major upgrades in complicated systems. So for example, with OpenStack, that can be a real pain in the rear to do upgrades on. And you have to go through a very specific process. And we've gotten it to a point where I can deploy a multi-node OpenStack setup where it's usually a controller and a compute node. And then I think actually I have another node that acts as a Ceph server even. And then I can switch over to the branch that has my new version that I want to upgrade to, and I can converge it the way I normally want to. And then I can test and see, like, is this working the way it's working as I intended it, or am I having issues with it? Is there something new that I need to deal with? And it usually catches most of the issues that I've seen before. The same thing happened with Ceph. I hadn't actually done an upgrade between the major versions before, and I was like, okay, how's this going to work? I don't want to break all my storage. And so I was able to easily replicate that in using this environment and so forth. So it's been really great. The other thing that's really nice is that if you maybe upgrade to a newer version of a upstream cookbook, if you're using a sous chef cookbook and they did a really big change, a lot of times, we're still using a lot of the older cookbooks that aren't resource-based quite yet. And so we want to make sure that the way we expect it to act in a multi-node situation is exactly the same way. And so that's been really, really great to be able to do that. So that's kind of our use cases of why multi-node testing is really important to us. And the other thing is that since we do a lot of things on bare metal, and we deal with a lot more complicated systems in that way, we really need to be able to do that. So there's 3 components that you really need to be able to have to get this working right now. You need to have Test Kitchen, obviously. And then you also need to have the Kitchen Terraform plugin, which is managed by the new Context folks. And it looks like they're supporting the latest Terraform, which is great. I'm currently using the latest .11 for now. And then you also just need to have Terraform installed on your system. So it's pretty simple to make it work. Now, Kitchen Terraform isn't included in Workstation or DK, but that's okay. You can easily just install it and it should just work. So here's the thing that I really ran into. So Terraform has a Chef provisioner, but the provisioner only works if you have a Chef server. It does not have any native functionality for Chef 0 or Solo. That probably could get fixed eventually, but in my use case, I just couldn't make that work. And so I really didn't want to spin up a test Chef Infra server. It's overkill, it would take too long. I just need a place to be able to upload my cookbooks, put in maybe some roles and some attributes and be done with it. So I've been really familiar with how Chef 0 works in Test Kitchen and so forth. And so what I finally realized is what I could do is I could create a VM that has Docker already pre-installed and running on it. I could deploy a Docker image that has Chef 0 already there, and then I can configure Terraform to point to that exactly. So that's essentially what I did. So the key part of this is if I spin up a Docker image, right now I'm using the CentOS Atomic image, which already has Docker pre-installed. You can make your own image that does that as you want. And you can pull the IP address for the virtual machine and use that in Terraform and do that. And then how I deal with the cookbooks is I run Burke's vendor locally and I put it in a directory. I create the fake validator keys and client keys, and then I just upload it up there. And then everything after that works just normally. You use the Chef provisioner, point it to the Chef 0 instance, and it will automatically bootstrap and everything will work. One cool thing about this way is that other than what you normally would have with Kitchen, I can run Chef client on these nodes and it would be just like in production. So I can just run that. I can run knife commands and I can play around with it if I want to, and it acts pretty much just like in production. So it's quite nice. So let's talk about this container. So if you don't know, Chef 0 is an in-memory implementation of servers. Really simple way of doing it. There's absolutely no security, but it's really fast. So you probably want to fire off this VM from the world, because you don't want to have it accessible out to the world. But it does need to be accessible to the nodes that need to talk to it, obviously. And the container is really simple. I install Chef Infra, I expose the port that Chef 0 is on, and I bind it on all interfaces. So here's what the Docker file looks like. I have the name of the container that we already use. You're free to use it, or you can use your own. But basically, I just install it like I normally would, and then I just have the entry point be Chef 0, and I open it up, and everything just works. It's really, really nice and really, really simple. I don't have to keep up with the versions that much unless they change Chef 0, but I don't think they've really made that many changes. But this has been a really simple way. I probably could trim down the size of this quite a bit and just do like a gem install of Chef 0, but this is just as easy, and I know that that package works and it does what it needs to do. So the next part is that you need to have a local knife config so that you can interact with this Chef Zero server. So the one thing you want to do is you want to make sure it's not stored in a location that knife might look automatically. The thing there is you don't want to accidentally run a knife command that uploads everything to your production server if you have things set up that way. So I generally put it in a separate path in the structure, like under, I think it's like test integration, and I think ChefConf or something like that. The other thing is that in the knife config, I set a Chef Zero environment variable, which gets used and set by Terraform to set the IP address. So it can dynamically change where that's at. And the other thing is setting the various paths relative to the location where the knife.rb file is. So you want to be able to tell it where all these cookbooks and everything are actually at. So here's an example of what it looks like on our example. We have a very simple knife.rb. We set the node name, we have a validation, we set the chef's URL. So here we're setting this right here to where we have it going. And then all these other things are pointed in relative locations of where this file is at. So this way I can run knife commands if I wanted to in the directory of this cookbook, and I wouldn't affect, it would touch production, but it won't affect this. If I set the chef server and I point it to this config, then it'll work properly. And we have some ways of kind of automating that way a little bit as well. If you're using encrypted data bags, you can set that in here as well. Anything you can do in knife.rb, you can do it in here. So we use a Rakefile to kind of simplify how we invoke all of these commands. It's just a simple way for us to do it. There's obviously probably other ways we can do that. But what we do is we automatically create the fake client and validator keys. We run the Burke's vendor cookbooks. We store it in that known location. And then we basically just run knife upload up to the chef server, and everything's there. So here's an example of what the Rakefile would look like. This is just parts of what we would have in ours. But here the main one that we would run is knife upload is the command we would run. And that has the dependencies for creating the key and Burke's vendor. So if you look down here, we can see how we automatically create the keys. We run Burke's vendor into the cookbooks directory. And then here we actually just force it to upload using this knife config. So this is how we ensure we do it in the correct place and we don't accidentally upload it to the wrong place. So this works pretty well. I probably could find a better way of doing this, but it's working for us. Now let's dive into the Terraform configuration. So the example we're going to do is keep alive D, which deals with managing virtual IPs among many things. So we have it set up where 2 nodes are running keep alive D, and they're managing a virtual IP. We have our wrapper cookbook available, although I think some of our dependencies might be in private repos, unfortunately, but you can figure that out later. But you can at least see the configuration of this. So the variables are what you want to be able to easily override, or you want to set in one place and use in several locations. So that's things like maybe it's how you set the version of Chef Infra you want to have, or the version of the images that you want to use, and so forth. Outputs are usually just things for IP addresses for all the nodes involved, and that can get used internally with either scripts or internally with Terraform. And it's also useful for debugging, so you can be able to run a simple command and SSH into the nodes without having to look up the IP address. So let's dive into some of the variables. So here's an example in the OSL Keep Alive wrapper cookbook. Right now we're using Chef 14. We set the atomic image. So I should mention all of the examples I'm using today are with OpenStack. So if you're using any other cloud, just look at the documentation in Terraform and adjust it as you need it. It should basically translate over to anything else. So everything here is pretty specific to OpenStack, but it should work pretty well otherwise. And so here I'm setting the name of the images that I'm using. I set the SSH key that I want to use, the username to SSH in, and then I have some things like the network that I want to have set up for the instances. So it's pretty simple. Output, here I have 3 outputs. I have the Chef 0 instance, and here I'm setting the network, and I'm getting the IP address for that. And then the node 1 and node 2 are the 2 different nodes that are actually running. So I can get those IP addresses pretty quickly with Terraform. Now, this is pretty specific to what we're doing with Keep Alive D, but I wanted to kind of show you as a working demo example. So with Keep Alive D, we like to have it on a specific network so it can talk back and forth to each other. We also don't want it to get into the wild because it does the verb packets can kind of go out and make things a little confusing. So we create our own private little network on OpenStack. And then we also create a separate subnet in here. And we want to be able to test it. We want to have that separate there so that we can do everything we want to do. So we just kind of set our private networking there. And the key thing here is that we set ports, the ports for the, which is basically the IP addresses for the nodes, the private IP addresses on the private network. We want to make sure that we have port security off, which is kind of the default firewall feature that OpenStack has. I think it's similar in other cloud platforms. We need to turn that off so that Keep Alive D can talk correctly between the nodes and be able to fall back and forth. So we were able to do that. That was one little nitpick that we had to figure out. Actually, my student, Andrew, worked on this quite a bit on this cookbook. I basically said, hey, I did this in a few places. Go ahead and let's fix all of our other ones that we've been doing this multi-node stuff with and get it going. Because before this, we actually were using Chef provisioning, which has been deprecated for a long time. And when Terraform finally came out, it looked like a really good viable option to do this. So here we're setting the different ports. Here we have the network that it's connected to, and then we have the IP address that we want to assign it, so it's already there. Now here's the magical part, setting the Chef 0. So this is creating a new compute instance VM with Chef 0. I'm pulling in the variables that I had in there, and I'm setting the flavor as some security groups. And then here's the magical part where I basically run a simple little inline script that waits for Docker to start up. And then if it starts up, just run Docker, pull in my Chef 0, expose the port, and be done. And so that does that. And then after that, once that gets done, it'll run a local command that runs the knife upload command. And then we'll grab that knife or that Chef server environment variable from Terraform, and it properly sets that all up and it runs it properly. And I'll show you an example of this running here in just a little bit. Now this is the first Keep Alive D node we have. So this is node 1. It's pretty simple what we have set up. So we set the network port that we had there. We have a run list here that we have set. Here's the key part where we set the server URL to be the IP address of the Chef 0 instance. And then we point the username and everything to the various things we want. And so this way we can set the Chef version to the specific one we want to have. So when we update to 15 or 16, eventually we can do that pretty easily and not have to change it in all the various places. So this will spin up the first node. And then for the second node, we add a depends on for the first node. So we don't want to deploy them both at the same time. We technically could, but for our case, we just want to be able to make sure that everything's working properly. So this will wait until node 1 is done, and then it will start building this out, and everything else will work magically in there. So let's dive into what InSpec looks. So doing InSpec with the Terraform provider is a little different than what you would normally do. So here we create a suite that's called multi-node, and we actually set up a proper controls setup here. So here I have an all spec controls that basically these are all of the tests that I want to run on all of the nodes. And then I have separate specs for each other node if I want to have other tests that I want to be able to do. And then this is the basic configuration for InSpec to kind of define everything. So here's an example of what it looks like for the tests that I run on all the hosts. So here I'm making sure, can I reach all of these IPs? Can I talk to the other node? Can I talk to the virtual IP? Can I talk to my own? I should also make sure that I can't talk to certain IP addresses. And then I also do a simple HTTP request. So we set up, in this case, a simple Apache server on that virtual IP. And we set the name of the FQDN of that node as the header or the body of the text of that website. So we want to make sure that it's actually running on node 1 because that's the node that we expect it to run on. So we make sure that on either host that it works properly. And normally these IP addresses in production would be public IP addresses, but since we just put this in a private network, it should function the same. For this, we have, this shows us the individual files that would have been in the node 1 and node 2 files. I just showed it in one slide here. So this is just showing that it's running the IP address that we expect. And this is the virtual IP, so we expect it to be running on node 1, but here we don't expect it to be running on node 2 in this case. And this is the part that we have in the kitchen YAML that we want to be able to do. So we have our normal settings up above, and then I have a multi-node suite that I have set up. So the driver, provisioner, and verifier are all called Terraform. So that's a little confusing in the beginning. But the verifier actually uses InSpec underneath. If you've used the kitchen Terraform plugin before, they had a refactor of how they had this set up in a recent release. And so this is the new method of how you have these set up. So this is, just look up the documentation on how that's all set up. But here we have the various controls we have. So I have here that I want to run it on all. I have it running on node 1. And here I just say, this is the node. This is where you get the output to connect and sudo and all of that. So it's pretty simple to be able to do that. One annoying tidbit that we kind of ran into, and I need to figure out a better way of doing that, is that we're in the middle of upgrading and getting our systems ready for CentOS 8. We use CentOS 7 currently in our production. And the way suites and platforms are set up with Terraform doesn't work quite natively. So you need to basically create a separate suite for each platform that you're going to do that with. And it looks a little bit ugly in the output, but it works. And I just exclude one of the platforms between the two, so I know what exactly is running there. But that's something maybe I can work with upstream to kind of work a little bit better. But that's one annoying thing. All right, now fun part, demo. So I've already taken the time to actually converge this because it can take 8 minutes. That's one of the downsides of doing this multi-node test integration, is that it probably will take a long time. In the case of the Ceph one, which I actually already also ran, it probably took 20 minutes to kind of converge everything. On OpenStack, I think it takes about 30 minutes for it to completely run. So, I mean, there's nothing we can do much better about that, but that's just kind of way it is. But then we can fully integrate everything. So first off, I'm going to switch over here, and I'm going to show you some output of me actually running it, so you can kind of look through it. So here I'm running the command. We're using a little bit older we're actually using DK on this system right now because we haven't updated everything. So it should work on the newer one, I think. But here we go. So here everything is using Terraform, and it just shows the output. So here we're running and creating the network. It's computing that, getting that all created, creating the subnet, creating the ports for the individual instances. And then here we're actually deploying that Atomic OS, which is the Chef 0 instance. So here it's waiting for it to come up, and then it finally connected, and it's pulling in our image and deploying it, and then it takes it a bit to do all of that stuff. And then it runs the Docker image, and there we go. And here it's running the local exec. So I'm running the knife command, and it's running vendor on the cookbooks. It's figuring out the dependencies, obviously. We don't use policy files yet, but I'm assuming you can adjust this to use policy files pretty easily. That would be much better to do than how we're doing it here. And so that's doing that. And then here's the knife upload. So it's going to finally upload it up to the Chef 0 instance. I have some data bags. It's uploading all the cookbooks and so forth. And so here we're adding creating the node 1. It's spinning that up. And then it does the regular converge. So it installs Chef. And then it does the bootstrap for us, connects there, and then it just converges and does everything automatically to get it set up. Go through all this output. And then now it's running node 2. It created the node 1, and now it's creating node 2. And so we're creating that, does the same thing, and goes through all of that. We look down here, it took a total of 7 minutes to do all of that, just to do the converge. And the nice output, it shows the outputs at the very end down here, which is pretty nice. So now if I want to do a verify, I can run just kitchen verify, and hopefully my instances are still running properly. We'll see how this runs. So here it's verifying node 1. Everything passes. Excellent. Now node 2. There we go. So now I can also, let's see here, what do I have here? Interacting with the nodes. So I could do this, I could do that, and then I could say Terraform output. Here, let me do this correctly. Node 1. So that should automatically get the IP address from that. And so I can log into this instance. And now I'm on node 1. I can see I have the virtual IP running there on that interface. If I wanted to, I could stop keep alive D to kind of test this. And we can see that it no longer has the virtual IP. I can log into node 2. And I can see that it has the virtual IP. And so if I run verify, it should fail now because it's not set up the way I expected it when we deployed it, but it's a good way to kind of verify everything's correct. So let's see what happens. Yeah, so there we go. Everything failed. So I could see that the IP address wasn't there. It got the incorrect value, which is what we expected. So if I log back into node 1, I can start keep alive D again. I think will that bring it back? Yep, there it is. It's back. And I can rerun the test. And there we go. We can see if everything's working properly. So this is really useful for doing debugging of stuff as well. And I can see like, okay, this is working how I expect it. I can test some certain failures. I could yank one of the nodes out and make sure everything works. So for example, let me go in here. Let me just reboot this node. And so there it goes down. I can run the verify and it probably will complain that it can't connect to one of the nodes, but I can also see how things are functioning. Yeah, connection failed. That's kind of what we expected. We'll wait for that to boot back up and see the state. Like, it looks like it's already back up. So let's see if everything is back in the state that we expect it to be in. I think we have the node 1 to be the primary, so it should switch back over to that node automatically, if I remember correctly. And there we go. Looks like it's passing. That's great. All right. So something else that you can do is if you want to rerun your Chef client, since this is all set up with Chef 0 and everything, I can just run Chef client as is on the node, and it'll pull everything from that Chef server, the Chef Infra, or the Chef 0 instance that we have running there. So we'll go through and I'll run all of that. It shouldn't take very long. There we go. So now let's say I'm doing some development and I want to change some settings in here. So let me see here. Let me look at my test cookbook and see. I might add something in here. I have it in the Chef provisioning. Let's see here. What should I change? Here, let me. Here, I'll change this to stopping Apache, just to see what happens. Okay. So now all I need to do is I need to run my upload again. Normally Kitchen would do this yourself if you do use the other methods, but here I'm going to run it manually. So I'm going to run Burke's vendor. I'm going to run the cookbooks. I'm going to upload it back up to that Chef 0 instance. Now I think if I do converge again, it won't do anything because, oh, what did I run into? Uh-oh, what did I break? Well, we'll see what happens. So yay for live demos. I have noticed issues sometimes of doing this. Let's go through here and see if it changes it. No, it didn't actually change it. Well, anyways, there's that example. The other example I wanted to show you was Ceph. So, and also, so you can run Terraform commands if you want. So here I can see the output everything. This one is a little differently. So I set a group, which is all the Ceph nodes. I have it set up where I have the 3 nodes, which are acting as the Ceph storage servers. I have Chef 0, and then I have another CephFS client that tries to mount CephFS to make sure all of that integration works together. And so I have a test here to make sure that all of the Ceph nodes are working correctly. So if you want to look at the Terraform for this is a little different in the kitchen, but I just create a separate system called Ceph nodes, and that runs it all separately on there. I can also make sure everything is sane with my Terraform and make sure everything's working as supposed to be. So we'll see how this works. Yay, that's good. I'm trying to remember other commands you can do. I can show validate or yeah, I think that's good enough for now. And then let me go ahead and run verify on this. And this one is a little bit more complicated because it's going to be running multiple tests. And this is where it's really useful. So I tested between versions of Ceph. I can see what's going on. So now it's going for the first node of the Ceph nodes, and it's verifying everything is working correctly with those tests. So everything is working as expected. All of the versions are set. Everything is working normally. All the nodes are up. So we'll see if this passes. This takes a little bit longer to run. I was going to spin up the OpenStack one, but I didn't quite have enough time to spin that up. And I figured showing you this other example that's a little more complicated was quite useful. I think this cookbook, OSL Ceph, is also public as well, so you should be able to see this. Although I have to update I need to push an update to the kitchen YAML because I realize this hasn't been updated to the newer syntax for kitchen Terraform. So now we're doing individual tests on each node. I'm checking to see that the services are running properly. And now I'm running it on the client. And this is the fun one. I check to see everything is mounted. I can see things. I can expect different content to be there or not to be there, and it works great. So that's kind of the demo portion of this of how things kind of work. And I kind of showed you this as well. So showing what it looks like when you run InSpec, you can see all the individual tests running. This is the one for node 2. And then here's some of the simple commands you can do. Also, here's a simple command you can use to, if you want to be able to interact with knife, you can just, as long as you have the Chef server environment variable set, you can interact it just like anything else. So I can run knife node edit, I can knife node all the other things I want to do. I can do all the various things, and it's using Terraform. If you want to go ahead and just run applied directly underneath with Terraform, you can do that and go from there. And I kind of showed you this already. Actually, I should update this slide that you probably need to run Chef client on the instance. All right, so how do you replicate this with the environment? Well, basically, look on the Terraform page, look at all the various providers. As long as Terraform supports the cloud environment that you're using, you just need to adjust your Terraform configuration to match your environment of what you do. So just look at the AWS, Azure, DigitalOcean, GCP, you name it. If they have it, or if you find a third-party plugin that does it, that's great. I didn't get a chance to actually test this on AWS or something else, but I'm assuming it's going to work just as well. You'll probably have to do a few other nuances and maybe to work it a little bit better, but I'm pretty sure it'll work. So that's the great thing. The only thing I wish Terraform had was maybe like a VirtualBox or a Vagrant kind of a setup, but it doesn't quite make sense either. It's kind of like, well, that's not really what Terraform is for. Because there's certain situations like I want to test this netboot feature that I want to make sure works, and I'm kind of like, how do I do that with this? I could do it in OpenStack, but it would be kind of weird. It's kind of a different way of doing that. And I'm sure there's other ways that I can invoke uploading the cookbooks and managing everything with Rake, whether it's with delivery or something else, but that's just kind of what we have there, and it just works. So with that, anybody have any questions? Here's my contact info, and hopefully everything made sense and I didn't go through this too quickly.
That was great. We've got a bunch of questions. So Nicholas has been putting in a bunch of questions here. You've answered parts of some of them, but we'll just go back and sort of revisit and clarify some things. So the first one was about Berkshire. So you did kind of mention that you guys haven't started sort of migrating to policy files, but what kind of things would we be looking for that would be different between, say, Berks and Berks vendor and policy files? Like there's a big kind of a migration process that we need to go through since you're using Chef server, but on this workflow particularly, is there?
I guess a lot of that would depend on, here, I'll go ahead and close that off. I think a lot of that depends on how you're using your policy file. Are you still needing Chef server? Of course, this is dependent on my limited knowledge of policy file and how you interact with it right now. But if you're using Chef server, you would basically probably change the commands to create your. I'm trying to think. You would still want to run the same commands and then publish it up to that Chef 0. I'm assuming Chef 0 can handle that. I haven't tried that. I don't know.
I'm not sure of too.
I would have to test that. So that would be one thing. If that doesn't work, you could probably just upload the. I think you can make tarballs of the output from policy files and then just put that on the nodes and then just run Chef solo that way.
Yeah, there's a similar vendor process for that.
Yeah, there's a similar way of doing that. I wish I had time to have gone through that and tested that myself, but I didn't quite get there. So, yeah, I mean, also if
you know,
say that again.
There's always next year.
Always next year, yeah. That's kind of my goal is for us to switch over to policy files in the next year. But yeah, I think the process would be simplified, and you would probably want to adjust it a little bit. You may or may not need the Ceph 0 instance, but you may just need to create one and then just not have anything there to kind of get it to deploy, and then just run a different bootstrap command and go from there.
Yeah. All right. This one's kind of in depth on InSpec. It might be a little bit out of scope, but we'll see what we can get to here. For execution strategy for Chef InSpec, is InSpec installed into the nodes and then sends the test results somewhere, or is Chef InSpec triggered from, say, an automate to run on a set of nodes and test results sent back to Chef automate? So for your workflow here in particular, it's the first one, right?
Yeah, the InSpec is installed on my workstation here, and it's executing it remotely onto the system. InSpec is not installed on the remote nodes. We don't use Chef Automate, so I haven't tried seeing how I can get that integrated, because this is just for doing cookbook development and testing in the multi-node environment. But I'm guessing you might be able to. You would have to dive into the kitchen Terraform project to see what they have in there, but that's currently how it works. I mean, it works basically the same way that Test Kitchen works right now, where you have your local InSpec install, and then it just connects remotely using the target that you can with InSpec.
Yeah, the train stuff underneath is like super wide kind of connectivity, so it takes all the commands across itself.
Yep.
And as far as the automate stuff goes, I don't have a clear up-to-date version of that, but we can post some additional references for automate in the notes as well. Next one, multi-node configuration in the YAML file. Are we able to parallelize the convergence on the individual nodes?
Yes, you totally can, depending on how you have things set up. So I've been doing some of these individually, because when I do it in production, that's how I would set up a new instance anyway, and it just kind of depends on the software you're doing. So certainly, it all depends on how you have your Terraform configured. If you don't have things dependent on each other, then it'll just try and do everything in parallel as much as you can, I think. I don't remember quite exactly. There might be a separate setting for that as well. But generally, let me see here.
Yeah, actually the next question is about running concurrent option with the -c.
Yeah, I don't know how that is done with Kitchen Terraform, but there might be an option for that somewhere. Yeah, I'd have to look on their website and see if they have any setting for that. But you could probably run it manually too. I mean, in theory, you could just run Terraform first instead of running Kitchen and doing all of that.
True.
I think.
Yeah. Use those as
but Kitchen really ties in the verifier part is what's really going on.
Yeah. All right. The next one about the resource that didn't take effect when you ran Chef client. I'm going to do some debugging here maybe. Probably could it be because the recipe in the cookbook is vendored to a specific path and Chef client actually reads from that vendored path?
That was actually an issue with how it was up. My knife upload broke for whatever reason. And I've had that happen a few times as well. I don't know what happened. Let me try it again here in the background, but it didn't get completely uploaded to the Chef client or the Chef 0 instance. Yeah, it was running here and there's some bug somewhere. So it didn't actually upload the new cookbook to the Chef server, the Chef 0 server, I should say. So that didn't get updated, and that's why that's there. That didn't run.
Awesome, cool. And Nicholas also says that he just wants you to know that the presentation was awesome. So that's great. Does anybody else have any other questions? There's a lot of stuff in here, a lot of moving parts. So this is your chance to ask Lance all about all this crazy business here. So anything else out there in the world?
Yeah, and if any of you try running this or are interested in how it might be useful for your own environment, let me know. I've mostly been trying to get this working in our own environment because it's been really useful, and especially our students are able to finally kind of understand how these all kind of interconnect, and we don't have to spin up the entire infrastructure manually and go through all of that. So it's been quite a nice learning tool for a lot of folks as well.
All right. Well, I posted your GitHub link there in the chat too, if anybody wants to copy that out. You guys have a lot of resources in your GitHub repository.
Oh, we actually have a separate organization for our cookbooks.
Oh,
let me get that really quick in there. We separated it for our own purposes. So any of our public cookbooks are shown there, and some of them are forks of things and various things and stuff. But yeah, that's the place where we have all of our cookbook stuff.
Awesome. All right. Anything else, folks? All right, we will let you go. Thank you very much for coming.